You could detonate every nuclear weapon on Earth at once, and the universe wouldn't even notice. That's not a metaphor. It's a problem. Because if our most powerful weapons mean almost nothing out there, then what does power even mean? Here's the unsettling part. Humans have already built over 12,000 nuclear warheads, enough to wipe out civilization many times over. But what if we pointed all of them, not at each other, but at the entire solar system? What happens next isn't what you think, because every planet reacts differently. Some ignore the blast completely. Some turn it into something even stranger. And one reveals just how small we really are. So let's start at the closest target. Mercury, a dead, silent world. No air, no clouds, no protection. And that changes everything. Because on Earth, a nuclear explosion is all about the atmosphere, shockwaves, firestorms, mushroom clouds. But Mercury has none of that. So what happens instead? A flash. No sound. No pressure wave. Just raw radiation. X-rays and gamma rays, slamming directly into the surface, and instantly vaporizing it. But here's the strange part. Mercury doesn't just absorb the hit. It rings. Like a bell. A single massive explosion would send seismic waves racing through the entire planet, wrapping around it, colliding on the opposite side. And when they meet, the ground could crack, miles away from the blast. Pieces of a planet thrown into space. But that raises a bigger question. If a nuke can shake an entire planet like that, what happens when we try the same thing somewhere with way more atmosphere? Or way too much of it? Venus should be easier to destroy. At least, that's what you'd assume. But you'd be completely wrong. Because Venus doesn't just have an atmosphere, it has too much of it. 92 times Earth's pressure. Imagine standing nearly a kilometer underwater. Now imagine detonating a nuclear bomb there. That's Venus. So what happens? The explosion gets crushed. Literally. The pressure is so intense that the fireball can't expand properly. The energy gets trapped, compressed, and suffocated almost instantly. And this is where it gets weird. Instead of a massive blast, you get something closer to a collapsing bubble. A brief flash swallowed by thick clouds. From space, you might barely even notice it. It's like throwing a match into a burning furnace. Useless. But that's not even the craziest part. Because while Venus smothers explosions, the moon does the exact opposite. No air, no resistance, no limits. If you detonated a nuke there, the surface wouldn't just vaporize. It would explode outward in every direction. Dust, rock, debris, all launched into space. And because the moon doesn't absorb energy well, it would start to vibrate. For hours. The entire moon, ringing like a gong. Now here's the twist. Humans have already bombed the moon. Not with nukes, but with explosives. And long before that, there were actual plans to detonate a nuclear weapon on it. Why? To show power. But think about that. If a nuclear blast on the moon looks like a new star in the sky, then what would happen if we aimed that power somewhere far more fragile, or far more dangerous, like our own planet? We already know what happens when you nuke Earth. And that's what makes this part terrifying. Over 2,000 nuclear detonations have already happened here. In oceans, in deserts, even high above the atmosphere. And every time, the result is catastrophic. Shockwaves, firestorms, radiation. But here's the part no one expects. Even if we detonated every single nuclear weapon at once, Earth would survive. Let that sink in. All 12,000 warheads. One location. One moment. The result? A massive crater. Around 10 kilometers wide. A global nuclear winter. The collapse of civilization. But the planet itself? Barely scratched. And this is where it gets uncomfortable. Because it means our most destructive weapons aren't actually powerful on a planetary scale. They only feel powerful because we're small. But what happens when we try to use that same power to change a planet? Like Mars. There's a theory, nuke the poles, release carbon dioxide, warm the planet, terraform it. Sounds bold. But here's the twist. It backfires. Completely. The explosion kicks massive amounts of dust into the thin atmosphere, blocking sunlight, cooling the planet even more. A nuclear winter on a frozen world. And worse, we'd destroy something priceless. Ancient ice. Records of billions of years of history. Possibly even clues to life. Gone. Forever. So now the question changes. If nukes can't destroy planets and can't fix them, is there anything in the solar system they can actually affect? Or are we about to hit a limit we can't cross? If you want to test the limits of destruction, there's only one place to aim. Jupiter, the largest planet in the solar system, more massive than all the others combined. So what happens if we throw everything at it? Every nuke, every warhead, all at once. You'd expect something dramatic, a massive explosion, a visible scar. But what actually happens? Almost nothing. A brief, glowing bubble in the clouds, swallowed within seconds by storms thousands of kilometers deep. Gone. Like it never happened. But here's where it gets insane. We've already seen something hit Jupiter with the force of hundreds of millions of nuclear bombs. A comet. And the result? A temporary mark. That's it. No explosion tearing it apart. No chain reaction. No transformation. Just a bruise on a giant. And that raises the ultimate question. How much energy would it actually take to destroy a planet like Jupiter? The answer? So large it barely makes sense. You'd need about 100 quadrillion times Earth's entire nuclear arsenal. Not more nukes. An impossible number of nukes. And even if you had them, you'd still face crushing pressure and unimaginable heat just to reach the core. So the biggest target in the solar system is also the most untouchable. But that creates a strange realization. If the biggest planets are invincible, maybe the real impact of nuclear weapons isn't about size. Maybe it's about choosing the right target. Because there is something in the solar system that nukes can actually change. Not planets, not stars, something smaller, faster, and far more dangerous. Comets. This is where everything flips. Because unlike planets, comets are fragile, loosely held together, easy to disrupt. And if one of them is heading toward Earth, we don't need to destroy it completely. We just need to nudge it. A single well-placed nuclear blast could alter its trajectory just enough to miss us. And suddenly, the most destructive weapons ever created become tools of survival. But here's the strange part. That same power that can save us still can't compete with the universe. Because even the sun, our closest star, releases more energy every second than billions of nuclear bombs combined. Dropping a nuke into it would be like tossing a spark into an inferno. Meaningless. And that's the final twist. Everything we've built, everything we fear, is tiny. On a cosmic scale, nuclear weapons are not symbols of ultimate power. They're reminders of our limits. But that leaves one question. If we can't destroy planets, and we can't challenge stars, what happens when something out there decides to aim at us